Our project looked at cognitive load during puzzle solving. I'm Jenna Popko.
I'm Ross Aiello.
So to start, our objective was to validate our circuit used to acquire EEG biopotentials to ensure that it measures cognitive load reliably so that it can be used in a clinical setting. The circuit requirements are listed in the table, and our circuit met all of those requirements. And we tested the circuit by analyzing the cognitive load in the left frontal lobe of the brain during puzzle solving, involving different dimensions, 3D and 2D, and levels of distraction, fast sliding of the game board and slow sliding, using the proposed circuit. Our hypothesis was that cognitive load would be higher for three-dimensional puzzle solving and would also increase as the speed of the distraction increased, so the faster distraction would have produced higher cognitive load. We also hypothesized that subject number and subject answers to our questions related to puzzle experience would not have a significant effect on the data. And there is a picture of our circuit. So for materials and methods, our puzzle that we selected is IQ Puzzler Pro. It has games in both 2D and 3D. And we selected 4 different games for the 4 different runs. For the subjects, we used the 10-20 system, or a subset of the 10-20 system, for electrode placement. So there was an electrode on the left side of the forehead, FP1, and on the top of the head, FC, to get signals from the left frontal lobe of the brain. The questions that we asked the subjects prior to the trials was, do you do puzzles regularly? Do you like doing puzzles? And do you have experience doing IQ Puzzler Pro? Our experimental design involved 2 factors. The first one was dimension. Level 1 of dimension was a 2D puzzle, and level 2 was a 3D puzzle. And then our second factor was distraction. Level 1 was slow sliding of the game board, and level 2 was fast sliding. And this is a little bit of our table. Each subject had 4 trials, and each trial was a different combination of these levels of each factor. And there were 9 subjects total, with 4 60-second trials per subject. For data processing, we ran it through a program to reduce noise, and we found the mean frequency data points for the gamma band, which is the band most involved in puzzle solving. And that is the data that we later analyzed.
So for our statistical analysis, we used 2 different linear regression models to evaluate the data. Model 1 includes the factors and levels the experiment contained, ranging from distraction and dimension. And Model 2 expands on Model 1, which included the confounding variables and subject. And if the ANOVA value significance is less than alpha equal to 0.05, the model and the data are significant. When the model is significant, the factor of significance can be evaluated through Tukey-Kramer analysis. If the factor of significance is less than alpha equal to 0.05, then it is statistically likely that the factor is able to explain the variation in the data. If the factor is significant, then the standardized coefficient beta value can be analyzed to support our hypothesis. And then next slide, please. And then for our results, this is for the first model, given a significance of value of 0.841. That is very high. It's a lot greater than the alpha value of 0.05. The model is unsupported and more testing is required. And that is pretty much all we can do. And then additionally, as we can see from the histogram, the data is incredibly skewed right. And then for our box plot, we ran the data through. And then for the factors of the box plot, 1 would be 2D slow sliding, 2 is 2D fast sliding, 3 is 3D slow sliding, And then 4 is 3D fast sliding for each of the factor combinations. And next slide, please. Our results for model 2, we got an alpha value, significance value of 0.011, which is a lot less than the alpha value of 0.05. So this means that one or more factors are statistically responsible for causing the variation in the data. Then looking at the coefficient table to the right, you can see that only question 3 was yielded significant with a value of 0.001, evaluated at alpha is equal to 0.05. Additionally, the standardized beta coefficient is positive at 0.296, which suggests a positive correlation between experience and gamma band load. However, this is counterintuitive, as increased experience should lead to a less gamma band load. So again, the factors were again yielded significant, and other questions such as how much the subject plays puzzles and how often they play, if they enjoy puzzles, were yielded insignificant. Subject number is surprisingly also yielded insignificant, which is just a strong experimental design by us. And then as seen, can you go back? As seen from the histogram, the data does not, again, follow a normal distribution and is skewed right. And yeah, on to discussion. Given that the model was yielded insignificant for model 1, this can be attributed either to the model or the data, and the resulting statistical analysis cannot be fully interpreted, in either more testing or a different model is required. No conclusions about our hypothesis can be made using model 1. However, the hypothesis was partially supported from model 2. The subject performing the test was yielded insignificant, suggesting strong experimental design on our part, which also then supports our hypothesis. Additionally, questions 1 and 2 asking if the patients enjoyed puzzles and how often they played puzzles were yielded insignificant. However, question 3 was yielded significant with a positive correlation with gamma band load, which does not support our hypothesis. Factors A and B were again yielded insignificant, yet we originally hypothesized that they would be significant, as we hypothesized that fast sliding and distraction factors would affect the data a lot more.
There was some error with the experiment. There was extra noise in our data from movement artifacts and electrode placement. So like 2 of the subjects had consistently different data than the other subjects, most likely due to the electrode placement. Most likely the FC electrode on the top of the head, there was probably hair in the way. And then there was also some added noise for all the subjects from movement artifacts. So the subjects hitting the electrode wires while completing the puzzle. Despite this noise, the circuit still obtained biopotentials that resembled proper EEG signals. Thank you for watching.
Thank you.